Good morning, everyone. I'm Paul Colgan. I'm the Government Affairs Consultant for the Home Builders Association of Greater Chicago. And today's webinar is the first of what I hope to be a series of programs on how residential real estate can adapt to changing requirements to reduce carbon emissions. Today's topic is combined heat and power, a cost-effective and energy-efficient way for buildings to reduce carbon emissions while maintaining the operations and comfort of a large building. ComEd has one of the dirtiest electrical grids in the Midwest and nation, frankly. So simply switching to all electric today will have very little positive impact on the climate. CHP, however, using either conventional or renewable natural gas will have an immediate impact on the environment because it reduces carbon emissions today as soon as it's in operation. Today's speaker is Graham Miller, an energy policy analyst with the Energy Resources Center at the University of Illinois, Chicago. The U of IC is a partner with the U.S. Department of Energy Midwest CHP Technical Assistance Partnership. During the program, I ask that you post your questions in the chat, and we will do our best to get through them. Also, this program is being recorded and will be hosted on the HBAGC website in the near future. And Graham will take us through the advantages of CHP as a transition to the carbon-free environment. Graham, at this point, I'll turn it over to you.
All right, thanks so much, Paul. And thank you to everybody from the HBAGC. It's a pleasure to talk with you. I've kept my presentation to hopefully 20 minutes to a half an hour so that there'll be plenty of time for a Q&A or discussion section afterwards. But as Paul mentioned, my name is Graham Miller. I'm a senior research specialist at the University of Illinois, Chicago, where I am the assistant director of the Department of Energy's Combined Heat and Power Technical Assistance Partnership. So briefly, the agenda today is an introduction to this Department of Energy program, who we are, what we do. Then pivoting to combined heat and power concepts and benefits, defining what the technology is and how it's beneficial for the multifamily building sector. Then the business case for CHP, solely based on economics, what you need to consider when exploring CHP, what aspects make CHP the savings better. And then I really want to focus on the emission savings. As Paul mentioned, that's incredibly important today and will be much more so in the future. Even with natural gas, there's immense emission savings from combined heat and power in Illinois and in the Chicagoland region. I'm going to walk you through how, those calculations and those numbers. And then provide you with an overview of technical assistance offerings in Illinois. All of the utilities have incentive programs. We offer no-cost technical assistance, and I'll be walking through that. So who we are as the Department of Energy Technical Assistance Partnership. This is a program founded by the Department of Energy back in 2004, where UIC was the pilot program. And since then, it's expanded to cover the entire United States with regional centers throughout the US. The primary goal of this program is to provide end-user education, engagement, stakeholder engagements and education, but then our bread and butter is technical services. This is where we provide no-cost technical assistance to any interested end user in cogeneration, from large multi-megawatt industrial facilities to very, very small commercial and residential facilities. Our engineers will work with you and your sites to analyze energy loads, to analyze hot water loads, to see what technology might work and what the economics behind that technology will work. Again, here's a map of all the regional centers along with the Department of Energy headquarters team on the right. So let's talk about combined heat and power and what it is. This is a talk I give every Christmas when I'm with my family because they seem to have no idea what I do. But combined heat and power is a form of distributed generation, similar to solar and wind, but unlike solar and wind, it's not one thing, it's not one technology, it's a suite of technologies that work together. So it's an integrated system providing both thermal energy, commonly in the form of hot water or steam, and then electricity. And you're locating this equipment on site. Think essentially a boiler that generates electricity. Because you're using fuel and producing two useful energies, you can get fuel efficiencies 75, even 80% compared to separate boiler and electric grid, roughly 50%. So it can save money. Its efficiency translates directly into carbon reduction and utility bill savings. And I don't want to get too in depth in these numbers yet, but this image provides an overview of how and why combined heat and power saves emissions. It's directly related to its high end use efficiencies of generating electricity and taking the waste heat from that generation process to make hot water or steam for your facilities. And by doing that, and by most efficiently using natural gas, the emission savings are immense compared to what the grid would produce for the same amount of electricity and what your on-site boiler would produce to come up with a similar amount of steam or electricity. So even today, using natural gas, there's still a lot of CO2 savings, and there's forecast to be for the foreseeable future. And I'll be getting into these numbers in a few slides. But before that, I want to walk through what combined heat and power is, because I mentioned it's not one technology like a PV cell or a wind turbine. It's a suite of technologies that work together. It's a prime mover, in which case engine, similar to car engines. A microturbine, a fuel cell are the three most common for your market sector. And these are paired with some type of heat recovery mechanism that takes the waste heat from this generation process and then converts it into some useful thermal application. So as I mentioned, the most common are to produce hot water or to produce steam. So I want to start with engines, and I'm focusing this presentation on the three most common technologies we see for smaller commercial and multifamily units. Engines range in size from the larger industrial engines of 10 megawatts to the very small package engines of 10 to 50 kilowatts. They generally are excellent at producing hot water, although they can produce low pressure steam. They can even produce chilled water through technology called an absorption chiller. They have fast startup time and high part load efficiency. And out of all the technologies, this is the most mature technology. This is the cheapest technology, but on the downside, it does require the most maintenance of the technologies we'll be talking about today. This technology is essentially the same as that's in all of our car engines. That is all of our car engines. It requires oil changes, spark plug replacements, air filters, oil filters, etc. And that maintenance comes at a cost, generally provided by the equipment supplier. In this case, on this picture would be Caterpillar, but anybody that sells engine, and there's a very much.
Want to get lunch while we're watching this? Sure.
Please mute yourself.
Lunch does sound great though. So engines are the most mature and the least expensive technology, although they do require the most maintenance. So the capital cost is lowest, the O&M cost is highest. But we see, especially on the East Coast, a lot of engines, smaller package engines fitting in large multifamily units. One of the other more common technologies we see for small commercial and large multifamily are microturbines. These individual units range in size from 30 kilowatts up to 330 kilowatts, but they can be daisy chained together for modular package megawatts. So this technology excels at making hot water. They can make steam, but they are most efficient and they perform best when they're producing hot water up to 180 degrees, potentially 190 degrees. They're compact size and lightweight. And since they're based on inverter technology, they can improve the power quality at your facility. The downside of this technology is it's expensive. The capital cost is higher than that of engines. The benefit is because there's only one moving part, the maintenance of this equipment is far, far less expensive than the maintenance of engines. There are no oil changes, there's no spark plugs. You simply need to monitor this technology, and every 48,000 hours, go in for a major overhaul, which would be included in your maintenance package. So a big trade-off between the two. And unlike engines, these units don't need a full-time operator. They can be operated remotely by Capstone, Microturbines, or Flex Energy, the two of the biggest providers of this technology. And then last, one of the more promising technologies we see for the commercial building and large multifamily units are fuel cells. Now, fuel cells don't utilize combustion. It's an electrochemical process that takes natural gas, breaks it up into hydrogen, and then runs that hydrogen through the fuel cell to generate electricity. On some of the newer fuel cells, they get hot enough to generate low pressure steam, although this technology really excels at generating hot water. So the maintenance costs on these units are low. However, out of all three technologies I've talked about today, the capital cost of fuel cells are by far the highest. On the flip side, the emissions profile of fuel cells are by far the lowest. Because there is no combustion, these are the quietest units. They emit the lowest amount of pollutants of any type, including CO2 or any other type of air pollution. However, they do come at a premium cost. So on a very high level, what are the benefits of combined heat and power? Well, in all cases, combined heat and power is more efficient than separate generation of electricity, heating, and cooling. This higher efficiency translates to lower operating costs and lower emissions, but it does require an initial capital investment. As I mentioned, the higher efficiency does reduce emission of all pollutants, and especially CO2. CHP can increase power reliability and enhance power quality. We see this in all the time, especially on the East Coast, that multifamily units that have CHP systems, especially during Superstorm Sandy and other big weather events, didn't go offline, and they were able to maintain operation to provide their multifamily housing units not just with electricity, but also with hot water. And on-site electric generation reduces grid congestion and avoids distribution costs. It can save a greater amount of money. So let's talk about developing a business case. What aspects do you need to put in? What aspects do you need to consider when assessing whether or not CHP might be right for a new construction facility or a rehab of an existing building? So like all other energy projects, or like all other projects in general, economics are the primary driver, but resiliency and sustainability are becoming more and more prevalent. Generating your own electricity and thermal energy can also provide a hedge against rising prices. I don't know how many people saw on the Tribune or Cranes today and yesterday, but ComEd is undergoing, or is planning to undergo, a very large rate hike over the next few years. So generating your own electricity with natural gas can provide a good hedge against rising electric prices. So the efficiency of CHP is very high, and that can contribute to sustainability initiatives and reduce greenhouse gas emissions. But there are some risks with these projects, and risks that can be mitigated, but sometimes they come at a cost. So one of the risks is operating risks. Will the system perform as forecasted? You want to save energy, you want to save money by operating your CHP system, but if it goes offline, if it needs a lot of maintenance, you're not going to see the savings. You're just going to pay this large capital cost. So we see operating risks being mitigated using some type of third-party financing structures or vendor maintenance agreements, where the vendor, and all vendors do this, Caterpillar, Cummins, Flex Energy, Capstone, will provide a maintenance agreement that they can guarantee an uptime. And so those agreements can largely mitigate these operating risks. If the asset isn't performing as promised, there's a contractual mechanism to make the end user whole in that case. Also, fuel risks. What if the natural gas prices rise? I think we've already seen this in the past year, especially in light of the war in Ukraine. But this can also be mitigated to a large extent by hedging strategies using deregulated natural gas, which is available in Illinois. So making the economics work for CHP projects. To maximize economic returns, energy projects must run at full load for as many hours during the year as possible. As I mentioned, even when we're talking equipment comes at a significant capital expense, and you're only saving money when this equipment is operating. So you want to size the equipment such that it can run as near to 24/7 as possible. And that means essentially sizing the equipment to meet your site's thermal load, hot water or steam, because you want to be able to maximize the output and the consumption of both the thermal energy without radiating it to the atmosphere and being able to consume all of the electricity you generate. So for that reason, it's essential to build electric and thermal load profiles, which we do as the Department of Energy CHP Technical Assistance Partnership. So profiles must reflect minimum requirements as well as peak demand and take into consideration daily and seasonal volatility. The thermal energy profile should only be for facility equipment that will be offset for the CHP system and their operating efficiencies. So we would only count, in the case of your buildings, most likely the on-site boiler or steam generator providing process heating, domestic hot water for your facilities. We wouldn't take into account any other thermal use that CHP wouldn't be able to replace. And ideally, you should be able to create an hourly profile for a 12-month period. That way you can be fairly certain of system performance, identifying what size and capacity would allow you to operate as close to 24/7 as possible. And then lastly, to make the economics work, there are a lot of bonuses that should be considered. One of the primary reasons we see CHP going in the ground in all economic sectors, from large industrials to smaller commercial and multifamily units, is capital offsets. For example, is there a facility expansion that this can be paired with to minimize dedicated construction costs? Are boiler replacements planned in the near future? That's a fantastic time to look at combined heat and power. Instead of spending this dedicated capital purchasing a new boiler, that boiler cost can be thought of as a credit towards CHP, whereas then the cost of CHP is only the marginal difference between the cost of a boiler and the full cost of a CHP system. And then there are key construction issues impacting capital costs, and these are especially prevalent in small commercial and multifamily residential. Is there space inside the facility? If not, a container will be needed when purchased. In Chicago, and I wish I remembered the name of this building, but in River North, a multifamily unit installed microturbines, and they had a helicopter lift the microturbines to the roof to interconnect to the electric and to the hot water system. So that needs to be taken into consideration if there's space inside, and if not space inside, then where can we put this equipment? And then is noise level a concern? All of this equipment can be mitigated for noise, but it comes at a cost. So what are the decibel requirements of your facility? That's good to know going in when you receive budgetaries from equipment suppliers. Is there a value to be able to operate in island mode? If ComEd were to go offline, what would the value be to providing your tenants with uninterruptible electricity and hot water? All of this technology can do that, but it does come at a cost with extra switchgear required. And then are there any utility rebates? We'll talk about this in a few slides, but yes, in Illinois, there are utility rebates on both the electric and natural gas side, and there are no caps on what ComEd will pay. Previously, ComEd had a cap of $1 million or $2 million. Now there's no cap. So the more efficient your CHP system, the larger the incentive check will be. And currently in the United States, there's a 10% federal investment tax credit for eligible CHP systems. And now I want to focus on the topic that Paul mentioned. So without getting too into the weeds, and this is a lot of what I do at the University of Illinois Chicago, but I wanted to provide 2 slides to demonstrate that combined heat and power, even when using natural gas, provides as much, if not more, CO2 savings than similarly sized solar and wind installations. And most people's immediate reaction to this is that that's absurd, that's ridiculous. Combined heat and power uses natural gas. Wind and solar have no emissions whatsoever because, the sun and the wind, there's no CO2. And that's absolutely true. The electricity that solar provides and the electricity that wind provides come at a 0 carbon cost. However, when you compare similarly sized installations, you also need to compare an annual capacity factor. And for those of you that don't know, capacity factor is essentially a percentage that the unit can operate as a percentage of its maximum output. So if your maximum output is, in this case, 20 megawatts, an annual capacity factor that's fairly standard, if not conservative, for combined heat and power would be 90%. That is, throughout the entire year, combined heat and power is putting out 90% of that 20 megawatts because it runs on natural gas, and unlike solar and wind, natural gas is not interrupted by seasonality. Whereas and these are US average numbers. So in Illinois, the capacity factor for solar and wind would be lower than this. But in the United States, the capacity factor for solar is roughly 24%. The capacity factor for wind is 34%. So that means you install 20 megawatts, but you're only going to see for solar 24% of that being generated on an annual basis. And for wind, 34% being generated on an annual basis. So the amount of electricity you're generating is completely carbon free. It's just far, far lower than that of CHP. One of the other aspects that's crucial in understanding the CO2 savings of CHP is that it also provides useful thermal energy that would otherwise be generated by an on-site boiler or steam generator. This thermal energy, the carbon cost of that thermal energy is already built into the gas being consumed by the CHP system. Whereas for utility wind or utility solar, those installations would need an additional gas boiler to provide that same amount of thermal energy, thus increasing their carbon a little bit. And then the last aspect that's crucial to understand about how displaced carbon is calculated is that you need to understand what resources are being turned off when CHP is generating, or when solar is generating, or when wind is generating. Right now in Illinois, we have a lot of nuclear power. We have some solar, not much, and we have some wind. But as Paul mentioned, we have a lot of dirty energy. There are a lot of natural gas plants. There are even some, the coal plant in Springfield. These are the resources that are being turned off when you install CHP or when you install solar. It's what's called marginal resources, those at the top of the power stack that are the least efficient, that essentially come on to serve the peak of every day. Think the hottest day of the summer when we all have our air conditioning on. This is the dirtiest power on the grid. So combined heat and power is replacing the dirtiest power on the grid. So even though it does emit carbon, the carbon it releases is far, far lower than the carbon that would have otherwise been released from these marginal resources. And so with all those 3 points, we can get a greater amount of carbon savings from natural gas CHP than we can from utility solar or utility wind, because the capacity factors are higher, because there's thermal energy being provided when the other technologies cannot, and because, well, for all technologies, we're taking into consideration these marginal, really dirty resources. So one of the most important aspects of decarbonization is this quote on the bottom. This comes from the Time Value of Money from Larry Stein's Carbon Leadership Forum in April 2020. So because emissions are cumulative and because we have a limited amount of time to reduce them, carbon reductions now have more value than carbon reductions in the future. And that makes perfect sense. To meet our 2030 targets, to meet our 2050 targets, we need to reduce carbon now. Reducing carbon in 2051 or 2031 does nothing to meet those targets. And the atmosphere doesn't care where the carbon reduction is coming from. It doesn't care if it's coming from solar PV or wind or natural gas-fired CHP. All it cares about is achieving those carbon reduction goals, achieving that CO2 reduction. And today in Illinois, today in Chicago, natural gas-fired CHP can provide as much, if not greater amount of CO2 reduction than utility scale wind or solar. And I want to take that table and demonstrate it in a different way. This analysis was completed by a company called Sterling Energy. And this compares utility in the southeastern part of the United States. Actually, the same table as we saw before. The y-axis is tons of CO2 avoided, and the x-axis is years of installation. So we see the green line reflects the CO2 savings from CHP, whereas the blue line is wind and the yellow line is solar. Now, even though all of the electricity wind and solar produce come at a 0 carbon score and avoid the full marginal displacement of these dirty coal and natural gas plants, because CHP saves a greater amount generates a greater amount of electricity with higher capacity factors, it can save a greater amount of carbon. So we see in this analysis that CHP saves more greenhouse gas emission in 6 years than the same capacity solar photovoltaic does in 35 years. And this is just a reflection of the higher capacity factors, the high efficiency of CHP, the use of thermal energy from CHP, and the fact that the grid is undergoing decarbonization. This wouldn't be true if the grid were completely decarbonized. If the grid were 0 carbon, then CHP would emit more carbon. But because the grid is quite dirty now and is forecasted to be quite dirty with marginal power for the foreseeable future, CHP can save an enormous amount of carbon. So I did want to include a project snapshot. There are many projects in New York and the New York City area that have combined heat and power. This is largely due to a very valuable incentive program that existed for many years to provide direct incentive to developers or to sites themselves. So this is on Roosevelt Island. It's an island between Manhattan and Queens. A multifamily housing unit. This is no commercial. This is all multifamily housing. This site uses 4 reciprocating engines provided by a company called Tecogen, 4 100 kilowatt packaged modular CHP systems for a full capacity of 400 kilowatts. The use of thermal energy provides space heating, space cooling, and domestic hot water, and runs at an annual efficiency of just shy of 82%. So you see these quotes from the developer and from the tenants corporation. So I'll just read the top one. Our 2009 electricity bill was over $2 million and rising when we started planning a CHP system. After a full year of operation in 2020, our electricity bill is expected to only be $400,000. That's a $1.6 million savings. So this system did receive an incentive. You can see on the box on the left, the bottom, there's a $761,000 incentive from the New York State Energy Office and a payback of 5.7 years. And there are many more of these throughout the New York region. And I do want to add one thing. All of these CHP systems that were designed for resiliency, that were designed to operate when Con Ed, Consolidated, their electric utility went offline, all of them did. So when the utility went offline during previous storms or outages, all of the systems designed to maintain operations, 100% of them maintain their operations. So let's talk about the services that we can provide you as the Department of Energy Technical Assistance Partnership. The middle arrow is what we see as the steps leading up to project installation, from high-level screening and preliminary analysis to a feasibility study, to an investment grade / design engineering study, and then to procurement, operations, maintenance, and commissioning. The boxes underneath are the services we provide. But let me sum it up in a different way. The purpose of our program from the Department of Energy is to reduce the barriers for folks like you to look at combined heat and power. So we essentially want to identify good projects, or as importantly, make sure bad projects don't go in the ground. And we do this through providing an initial qualification screening. That's a high-level look at annual electric and gas bills, boiler efficiency, some other factors to determine simple payback. From there, we can go out and get equipment budgetaries from Caterpillar, from Cummins, from Capstone Microturbines, whoever it is. We can model your annual thermal and electric load and then model equipment performance against that to come up with some type of project payback or pro forma to help you determine whether or not it's worth you or your tenant spending their own capital on a design engineering study to go through procurement, operation, maintenance. So we're that initial step that helps reduce the barrier by providing no-cost technical assistance to help determine if a project is worth moving forward or if it's worth walking away. So just a high-level overview of the initial technical assistance step through our Department of Energy Center, and that's the screening analysis. This is, as I mentioned, a high-level analysis to show site potential. It's quantitative, and then we take energy costs and consumption, CHP system sizing, and then we come up with an annual energy savings and system payback. And then we understand project drivers and site particularities. We judge everything based on payback. However, if metrics are different and we're seeing CO2 reduction become more and more prevalent, we can judge a project on its CO2 reduction potential. So before I get into study incentives, let's go back here. There is no formal application for technical assistance from our Department of Energy centers. All you need to do is email me and we can begin. Everything we do is confidential. We don't share any information with anybody outside of the Department of Energy program. However, if your site demands it, we are able to sign NDAs to provide an additional layer of protection. And yeah, there's no formal application. It's as simple as sending me an email. We set up a meeting to discuss. We make our data requests to you for electric data, gas data, or thermal data, whatever it is that our engineers determine that we need. We work with you to get that information. And then within a few weeks, you'll have our initial study back. And then we can delve much deeper into getting budgetaries, running hourly, load modeling, depending on what you need to help determine whether or not this project should proceed. So with that, I want to pivot quickly to the incentives available currently in Illinois. As I mentioned, all utilities in Illinois offer incentives. Ameren, Illinois, and which wouldn't so much be applicable to your group, but ComEd offers a high level of studies. This site focuses on gas incentives. So for studies, for feasibility studies, Nicor Gas offers 5 no-cost feasibility studies. And this goes beyond what we do as a Department of Energy Center to receive budgetary quotes from multiple suppliers to look at not just budgetaries for equipment, but also some level of budgetaries for installation. So Nicor Gas provides up to 5 of these per year. It is conveniently offered through the University of Illinois Chicago through my office. I have colleagues who operate this program. So if you're interested in this program and obtaining a completely free, no-cost feasibility study through Nicor, please contact me and I'd be happy to put you in touch with the program managers. Peoples and North Shore Gas also offer study incentives up to $15,000 upon project commissioning. But there is a cost share required. Now let's talk production incentives. These are the ones that really move the needle. ComEd currently is offering 12 cents per kilowatt hour generated for CHP projects with no cap on any incentive. The more for this, and we're very familiar with it, but we don't need to go through those details. But essentially, the more efficient your CHP system is, the higher this incentive check. You get 12 cents from ComEd for a kilowatt hour generated in the first year. You get $1 from either Nicor or Peoples or North Shore for every therm saved from CHP. So we've seen checks in your market sector for $500,000, $700,000. They can really decrease project payback and make these projects move. So high-level summary, we think CHP is pretty fantastic, and it can save carbon. It doesn't work everywhere, but when it works for the sites it does, there's significant energy efficiency savings, significant carbon savings, and significant economic savings. All utilities in Illinois offer incentives, and our Department of Energy program is here to offer no-cost technical assistance to help you explore whether or not combined heat and power might work for one of your facilities. So with that, I will leave you with my contact information. As I mentioned, there is no formal application for the Department of Energy Resources. You simply call me or email me and we can begin the process. So with that, I'd be happy to answer any questions if there are any. Paul, I think I'm going to be done sharing my screen unless you think I should leave this up.
Why don't we leave that up for a little bit?
Okay, sounds good.
Thank you, Graham. A great presentation. And I think that the impact of what he offers will become more relevant or important once the city of Chicago starts adopting requirements on carbon decarbonization of buildings. I'm part of the City of Chicago Building Decarbonization Working Group, and they've talked about a lot of different things. And they have a report that's supposed to be coming out. It was supposed to be out in January, in February, in March, and it's still not out here in April. So once it comes out, I think then we will have a better idea of what the requirements the City of Chicago will be putting on our industry. Because according to their studies, they say that 70% of the carbon footprint of Chicago comes from the built environment. Now, most people in other places say it's 40%, but nonetheless, it's a major issue. And they're going to be pushing buildings to make this transition. And part of the purpose of this program and other programs we'll hold is trying to give you, as building operators and owners, options that are cost effective, save you money, and also reduce your carbon footprint so you can meet whatever requirements the City of Chicago may throw your way. And with that, I'm going to start going to some of the questions in the chat. There was one about whether or not the slides will be available to you. Yes, Graham gave us a PDF of his slides. We will send that out to everybody who registered. We had a question here about the costs, upfront costs to build wind turbines and the power to build these different fiberglass blades and other things on the wind turbine. Yes, there is a big carbon footprint, front-end carbon footprint for the wind turbines. And they, I don't know, Graham, when you made your analysis between wind and CHP, whether you took that into consideration or not, but yes, to answer the question is, yes, there's a big upfront cost to build both solar and wind.
Yeah, that analysis, that the two slides did not take any what we would call scope 3 emissions into consideration. So the carbon costs of building any of the equipment. It just looked at the carbon when this is generating. So, and the building of wind turbines is definitely out of my wheelhouse, but the analysis I provided didn't even explore the carbon emissions from building PV or building wind.
Okay. Now, this New York City example is important because New York City has already imposed carbon reductions on their built environment. They already have targets and numbers that buildings have to achieve in the near future. And so CHP, and to my understanding, and Graham, you can help me out here, has become a very attractive choice in New York City because of these requirements.
Yeah, to my extent too. I do know that New York City is also having debates about gas hookups, if they're going to allow new gas hookups, which is a really big deal because this technology does provide significant carbon savings. And unlike other distributed generation technologies, it does provide huge resiliency benefits. But of all the installations, CHP installations in New York City, they've all provided significant carbon savings compared to purchasing electricity from the grid and having your own boiler.
Okay, thank you. The other thing too about CHP is that we're seeing developments in the natural gas industry where there's more clean hydrogen being developed, more renewable natural gas from anything from food waste, digesters to methane being pulled off of landfills and that, but there's a lot of development in that area. And we have this huge investment into the gas infrastructure. And frankly, a lot of the engineers who run our buildings talk to us about they prefer a gas source as their for their heat and power. And so they'd like to preserve that. So part of what we're looking at here is how can we utilize the existing infrastructure to the best benefit of not only the climate, but for you as a building owner and operator to reduce your costs while you're reducing your carbon footprints. And to me, that's very important because we don't want to see the city of Chicago imposing policies that cost you a lot of money. We're looking for options that allow you to save money while you're reducing carbon. Now, as I said before, if anybody wants to post a question in chat, please do. I want to make full use of this time with Graham.
Paul, let me make a comment to something you just said with renewable natural gas and hydrogen, which the CHP industry sees as vital to its future. So of the three technologies that I focused on in today's presentation, engines, microturbines, and fuel cells, all of these technologies, the baseline equipment that you'll buy today can operate on up to, I think, 30 or 40% hydrogen. And all of the major manufacturers of technology are developing or have developed technology that can use up to 100% hydrogen. So we expect to see in the CHP industry all equipment by 2030 able to use up to 100% hydrogen. Now, the issue is where's the hydrogen going to come from? And that is an issue, but the technology is already ready to use up to 40% hydrogen with no issues. And then by 2030, the baseline will be up to 100%. The second part is with renewable natural gas, and we're seeing a bigger and bigger interest in renewable natural gas. All of the technology, again, because renewable natural gas is essentially indistinguishable from natural gas, all of this technology can use renewable natural gas as well.
Okay, Mike Munson is asking, is the Home Builders Association part of the Midwest Cogen Association's coalition, which includes the IMA, to clean up the definitions of renewable energy resources in the Public Utilities Act? No, you're not, Mike. Yeah, I think with your advice, maybe we should. Is that correct? Go ahead if you want to explain.
Graham may know it because Cliff is, and Pat Sharkey is part of that, and we joined it as BOMA. Just we're for competition and multiple resources of energy. So it is something that you guys should probably join. Just my advice.
Yeah, I'm a member of the MCA, and Cliff is my boss at the ERC. So yeah, very familiar with Cliff and Pat Sharkey. But there is an important. The CEJA bill that was passed included combined heat and power. The carbon savings from combined heat and power defined it as renewable, with an important caveat that between now and 2035. The state is only going to be purchasing renewable credits from solar and wind. So the state defined all of these technologies as renewable, but then in a different part of the legislation said, we're only purchasing renewable credits from solar and wind. So it doesn't matter if you provide carbon savings. And so the MCA has been working, and from what I've heard and from everything I've ever read, policy in Springfield is difficult at best. They've been working to try to get the legislation to acknowledge that there are all these other technologies that were defined as renewable that do provide carbon savings. So who cares where the carbon savings is coming from? You should just be purchasing. So that's one of the big issues that the MCA is working on right now.
Well, one of the things I'm working with another entity is whether or not CHP generates a carbon offset, which can be sold into the carbon offset market. And that's something that we're working on. And so regardless of whether the state buys those RECs, there may be marketable carbon offsets that can be sold into the public market. And that's an option we're looking at. Now, we had another question here about how would the operation of a large natural gas powered generator to produce electricity for your building help with the compliance of future electrification programs?
That's a good question. I don't think it would hinder future electrification programs. you would be able to electrify your buildings just as you would if ComEd were your supplier. You'd just be providing much more of that electricity than you otherwise would have. So instead of electrifying your buildings and purchasing everything from ComEd or Constellation or what have you, you would then be generating most of that electricity. So again, your generation would act as a hedge against the cost of electricity for electrification measures, and could potentially provide your residents with lower cost electricity than through the utility.
And I would argue that CHP should be one of the resources that a building has, or options they have available to them to decarbonize. Because the issue here is decarbonization, not necessarily electrification. Electrification is used as a buzzword by some advocates to think that's the only way to reduce carbon emissions in our buildings. And I think what we heard today was that CHP has the ability to do that too. And so I would argue that whatever policy the city of Chicago or state of Illinois has, CHP must be part of the options available to the built environment. And it's not just new buildings, it's also retrofit. I mean, I think it's an important thing to say that older buildings can be retrofitted with this technology. And as I think that Graham demonstrated, that there are smaller generation packages that can serve smaller buildings, not just the largest buildings.
Yeah, and let me add one thing, Paul, because this is difficult. And because you're right, electrification doesn't necessarily mean decarbonization. It really is determined on where we get our electricity. However, because it is a buzzword, moving to completely electrify buildings, there's going to be much more popular and public support about doing that, because nobody's thinking about where the electricity is coming from. Everybody views electrification automatically as good for the environment without considering the carbon intensity of the electricity you're purchasing. So there is a difficulty in talking about CHP because electrification is such a buzzword.
Okay, thank you. Are there any more questions anyone has? I don't want to leave this program without you having an opportunity to ask your question and hopefully get a good answer from us. Please post them. But as I said to start the program, I expect to have more programs like this over the coming months as we try to address some of the issues for decarbonization in the buildings, or in our buildings. So stay tuned. I don't have anything specific at this time, but we are working on a program that's focused on small residential, small homes, single-family homes, small apartment buildings, and I hope to announce that in the near future. And if there's no other questions coming up, I don't see any. Thank you, Graham. It's been a pleasure to have you, and I really appreciate the information you've shared with us. And as I said, we will have this recording of this event on our website. And everybody who registered, I will send a copy of the PDF of the PowerPoint to everybody. So thank you, everybody that joined us today, and look forward to seeing you again soon. Thank you.
Thanks, Paul.
Thanks a lot, Paul.
Thanks, Paul.